Alright, here we go, Algebra 2. So we're going to begin our journey here and being able to go from factor to general form. And one of the things I first want us to do and discuss, right, as we go to do this is I want us to really understand this is the factor form of a quadratic equation, and what does this problem tell us? Alright, well, one of the things that it tells us is because it's x plus 3, since we have the x plus 3, it's the opposite. It's going to tell us that we're moving to the left, right? So this would be negative 3. And that tells me that one of my roots is located there. That's what factor form tells you, is where your roots are located at. Well, you look over here, we have x plus 4. So that's telling us that my roots is located right there. Oh, maybe I'll draw that a little less profound. Here we go. Right there at this location, and this is negative 4. All right, so that's what factor form tells us about a quadratic equation. So it's probably going to look something like this, right? I'm not 100% accurate on where the vertex is or the y-intercept, but it's gonna, gonna look something like that, right? Just like a little U shape, and it crosses right there at these intercepts there, right? So how do we go from factor to general form? Well, all we have to do is use the distributive property. So we start here. Well, we just go, what's x times x? Well, that's going to be x times x is x squared. Now we go over here and do what's x times 4, and that's going to be 4x. Right? Now that this x here has multiplied with both of these expressions, we go over to the 3. What's 3 times x? And that's going to be 3x. And what's 3 times 4? And that's going to give me 12. Right? Now all I do is just combine like terms. So I'm going to get x squared plus 4x plus 3x. Well, 4, 5, 6, 7. I'll get 7x plus 12. And there we go. I went ahead and went from factor to general. This is my general form of the equation. All right. Well, you might be asking, well, what does general form tell us about the graph, about the function's graph? Well, it actually tells us this 12 right here tells us the y-intercept. It tells us right here, the y-intercept, that this would be 12. That's where it would intersect. All right. So that's it. That's one way we go from factor to general. Well, what happens if we have something with a dilation? So let's go ahead and try y equals, let's do 4x plus 1, and then we'll do x minus 5. All right, well, now in this case, we have this multiplication by 4 in front, but keep in mind that that doesn't change where our roots are going to be located at. All right, well, since this is x minus 5, we're going to move to the right by 5, and my root is going to be located there. I'll change it with a different color. It should be right over here, okay? Now, since this is x plus 1, well, that's just moving to the left by 1. Oops, meant to do that with a different color. And we're going to go ahead and get negative 1 there, and my root's going to be located here, right? So that means that our function should look something like this, or something, I don't know, something to that extent, right? So how do we go about going from factor to general form to find that y-intercept? Well, we just proceed like normal, and we can approach this in many different ways, and I'll just start us off by just doing this. We just multiply the 4 with the x, right? Or here, how about we'll just go ahead and use the distributive property on this aspect here, just like we did on top here, right? So I'll just be consistent, why not? So let's just go ahead and we're going to do y equals 4. I'm going to put a big parenthesis around here, all right? And the reason why is I'm going to distribute this with this. X times x, well, that's x squared. Now I'm going to do x times negative 5, and that's going to be negative 5x. 1 times x is going to give me plus 1x. And then 1 times negative 5 is going to give me negative 5, okay? So here I'm going to get y is equal to 4 parentheses x squared. Well, the 5 at negative 5x plus 1x, that's going to give me negative 4x, and then minus 5. All right. Now all we do is we go ahead and distribute the 4 across. So 4 times x squared. So you see, we're just kind of taking it step by step. So we're going to get 4 times x squared, which is 4x squared. Then we're going to get 4 times negative 4x, and we're going to get negative 16x. And we're going to get 4 times negative 5, and I'm going to get negative 20. Okay? And so you can see that even if we have a dilation, even if we have a number in front here, like we did right there, this 4, right? Well, we just kind of proceed like we did before, distribute this entire thing out, and then simplify it, and then now we distribute the number, and then we get our final answer down over here. And you'll see here at negative 20, well, that's where my y-intercept would be, right here. It should be negative 20, and it should intercept there, right? So kind of as we learn these conversion patterns, we kind of learn a little bit of what it means on the graph of the quadratic function, okay? Hopefully that's helpful to understand how to go from factor to general form. Here's a basic one, and here's a one that's a little more advanced, right?